Hi, Shrikra sir. Can we start now?
Hello. Can you guys hear me?
Yes, sir. Yes, you're audible.
Yes, you are audible.
And
So, can we start the session?
so how do you guys usually do it? I don't really know much about
Yeah,
it. Is it just to like
yeah,
introduce the project and just talk about things? Are you guys going to be
y-
asking questions?
yes, sir. Yeah, I'll just give an introduction about you. So, hi everyone. I'm Karthikeyan, and it's a pleasure to introduce Mr. Shrikra Shastri, sir. Mr. Shrikra is an blockchain protocol engineer at Quai Network, part of domain dominant strategies, where he has been working since 2021 on code protocol design and systems level innovation. So his work lies at the intersection of distribution systems, economics, and the evolutions of proof of works, with a strong focus on mechanisms like POEM and SOAP that rethink how value and security flow through networks. He brings an unique blend of hands-on engineering expertise and economic insight, backed by a master's in applied economics from the University of Texas at Austin, along with an engineering background and from RV College of Engineering. So, Mr. Shrikra sir is particularly passionate about reimagining blockchain economics, scaling architectures, and building systems that align incentives at a fundamental level. So we are really glad to have you, sir. So, guys, so please join me in welcoming Mr. Shrikra Sastry, sir.
Yep. Hey guys. Thanks for the warm introductions.
Yes, sir. So we'll conduct two town halls monthly. So we
Mhm.
bring from on-chain Asia. So we bring in experts from different domains in Web3 and AI as guests to talk about in the sessions.
Cool. Yeah. Sounds like a great initiative. So I don't know how much you guys know about Quai, so maybe I can start there.
Yeah, sure, sir, sure.
So the main, I guess, since I joined, that was like even before we started with Quai. So we were kind of trying to think about how to scale proof of work chains, which, not many people have tried since Bitcoin and all the drama that went on with block size wars in the 2010s, and then came Ethereum, which also was a proof of work chain until like 2021, basically. But they also had some plans to scale, but they ended up moving to proof of stake. So then there was Casper, which also tried, which is also one of the bigger projects at the moment. And then we had like a very unique design that is very different and kind of similar to initial like Ethereum's plan for scaling, but right, like at the current state, it looks a lot different than anything else that is in the market right now. So we are a proof of work chain. We're scalable. We can scale the number of chains that we have in the network programmatically based on the number of users on chain, which is quite cool. Right now, we only have a single chain because it starts out as a single chain. It only makes sense economically if you have, let's say, like at least 1,000 transactions per chain to like scale further, which we are not at that stage yet, but we launched last year in like beginning of February. That was like basically 3 to 4 years of concrete development and innovation to get there. There are many like aspects about Quai that makes it very unique and very different. And then the whole idea was to be programmable money. So we have EVM, where I think we are the only EVM compatible proof of work chain. I don't think in any other proof of work chain you can do programs like how you can do on Quai. And along with that, we have like a UTXO ledger for payments that is designed to be like an energy dollar. So, and so we have these two token system that that basically completes a ecosystem that you need to do payments, and then you have programmatic store of value where you can do all your finance and DeFi stuff, and you can store your money and also use your money all in like a single platform without needing stable coins, which in the longer term is gonna be where things are headed, because there are like systematic risks to having stable coins as one of the primary assets, which has been the case. And then in an unstable world, and also like a continuously inflating economy around the world, and where the governments just keep printing more, devaluing their own currency, the need for having this exogenous like a token that is exogenously tied to energy, basically, which we think is like the most fundamental unit of account is kilowatts. So that is was our design criteria, and then we launched and we have like now both these tokens. So when we launched as well, we had like kind of a regular like emission characteristic, which changed drastically in the last December when we did the SOAP upgrade, where you could merge mine different chains when you mine Quai, and then the revenue from that would go back into buying Quai again. So, which was a drastically different tokenomics design, and that has never been done before as well, where you could scale revenue to the miners without having to like add extra tokens into the system. So that was done, and it has been running quite successfully, I would say. So we've done, I think we're about hit 3 million in revenue in the past 3 months. So that's been great. Every day there's close to 1 million Quai that is taken out of circulation from people who are trying to sell. And now we, in like day or two, I think in 2 days, so we're gonna have another fork, which is called the Singularity fork, where we're gonna improve the tokenomics basically by removing close to 90% of the upcoming unlocks. So that is that basically means that the amount of tokens that are in the market at the moment should constitute up to like 70% of the total supply in the lifetime of the blockchain, basically. So this has been like the history of Quai. there are many other cool aspects which I would love to elaborate further, but I think I don't know how
So
you
we
guys
have a
want to do it, but
so we have a question here from Ria Verma. Why
Mhm.
merge mine when your coin can get dumped as well?
Sure.
I'll repeat it, sir. So why merge mine
Oh,
when your coin can dump as well?
I mean, that's the nature of markets, right? So, a lot of people got tokens in the beginning, and to create a market, you need buyers and sellers. So I think there is close to 900 million tokens that are in the market right now. There's around few million coin volume every day, so there's constant exchange of hands. But merge mining is like that SOAP upgrade was completely different than that. So if you just take out all the supply of Quai that people already have, uh, uh, basically what merge mining and buying back from the revenue does is you can buy back the same amount that you give out, basically, which is not true for any of the other merge mine coins that mine with Bitcoin. So what they do is they still inflate their currency, which is quite different. But you cannot really do anything about the tokens that are already in the market. Over time, if miners are using this as a way to like DCA the token, then you also what will happen is the revenue of the merge mining will end up eating up the the sellers, basically.
Okay. Notice. So I have a question. Like, how does SOAP handle volatility in parent chain rewards?
uh doesn't handle, I mean, it quite varies, right? So we currently merge mine BCH and LTC, and Dogecoin. But for example, BCH is similar to Bitcoin, where the reward actually goes down over time. So that is a beautiful part about proof of work or like mining. That is, if you assume that miners are rational, which for the most part they are, they will not mine a coin which is giving them less than how much they're spending on the electricity. So usually there is like 5 to 10% delta or like profit. Currently for Bitcoin, I think it's closer to like 30 to 40% profit, depending on where you are. But so we don't really control it. We just take what we get. But the fact that if you assume miners are rational, that means they're mining us at the same rate they would be mining any other coin. So it would be equivalent, like in terms of the revenue that we get. So we don't really plan or anything for it.
Most of the people joining here will be starting into Web3 from second year in college or a third year student.
Okay.
So can you please explain how SOAP mechanism works in a simpler way for them to like understand easily?
Yeah, I mean, I guess yeah. If you want to start from the beginning, so you have to understand what mining is. So basically, it's just you're basically using energy to convert to compute. So you have like a hashing algorithm, which is all a hashing algorithm is. You take any random input, the output that you get is uniform. Basically, there is a hash field of 200 to the 256 number of possible outputs. And then you take an input, you hash it. That hash algorithm gives you like a uniformly random output. So if you do that like a large number of times, basically it's called like it converges to a Poisson distribution. what that does is, every once in a while, you get leading zeros in these hashes, meaning the hash output will start with zeros. So which is like the backbone of how like Bitcoin mining works, where you have these ASICs which are doing SHA hashing algorithm on the seal hash, that is the block hash, without the knots on the current state of the network, basically. So all the miners in the world, they're committing to what the state of the ledger is at the moment, and they will continue mining and produce these hashes. And then there is a rule on chain where which basically tells you which hashes are considered valid. So there is like a limit on how many zeros that you need to get to be considered a valid block. And then that's how like blocks get formed, and they come into like the next state of the ledger. So if you guys don't know about ledger, ledger is just like, you can think of it as a database. So where every node in the network is keeping like a copy of the database, basically. And then every miner in the network is committing to what the next state of this ledger should be. So okay, now if you understand how that works, then you can think of, so I talked about how like there is certain criteria on like which blocks are valid, right? At any point, which is basically determined by the difficulty threshold. Is like how hard, basically that's like a number that measures how hard it is to find a block. So so that is that. So now think of many chains having different thresholds, right? So because the emissions of every chain is different, so you can have many miners mining to a different target in each chain. So what like initial Bitcoiners found is that you could now cleverly mine many chains at the same time, because let's say I have a Bitcoin block, right, which has like a lot of zeros in the beginning, the hash of it. So that block could also be valid in some other chain because it will have like greater difficulty than any other chain. So the fact of doing it is called merge mining. So where you could have like you could basically mine many chains at the same time. And then Dogecoin came along, which was initially basically the merge mining Litecoin, and then that's how like the standard merge mining works. I can elaborate further if people have questions, but to keep it simple, in Quai we have like an architecture where we merge mine within ourselves of like, so we have like these hierarchy of chains that all get mined at the same time. So the higher level of the chain is only like found, like is found less frequently than like the lower level of the chain. Basically, so the lowest level you will find every 5 seconds, and then once every 10 seconds you'll find like the next level of the block, and once every 20 seconds you'll find like the top level, which we call the prime chain. So we also use merge mining, but with SOAP upgrade, it was completely different, where you could mine Quai, and then you could also mine like any other chain, which was like the upgrade we made to the network, where we put in the architecture so that you could mine Quai and also any other chain. So how this is different is, let's say, like in the case of Dogecoin, again, they merge mine with Litecoin, but majority of the revenue comes from the Dogecoin inflation that is happening. But SOAP like completely changes it, where you mine Quai and you mine Litecoin. This revenue from mining this other coins goes back into the network, meaning that goes into like a protocol that the foundation controls, and then it buys back Quai with it. So that is how I would like, simply put it, starting from merge mining, like mining, merge mining, and then, what we have at the moment.
Thank you, sir. That was a good example. And again, we have a question about miners. So how do we prevent miners from dumping? Isn't that a universal problem with proof of work chains?
Yeah, it is. I mean, there are many aspects that goes into how like price is determined, right? So let's think about like the whole range of it. If you're thinking about it as a problem. So let's look at, for example, Bitcoin. So I don't know, it's like 1.4 trillion market cap and probably gets traded like 50 billion a day. The amount of tokens that go into the market is like 40 million, which is like quite negligible compared to the amount of like volume, like trade volume that happens on Bitcoin. So in that scenario, like miners dumping has like zero effect, right? Which is like basically doesn't mean anything. They can like they can all sell, they can all keep it. Like it doesn't really matter. And when a new project starts up, it is actually a problem, which is what we saw with even in our case, where people just sell the token to cover their energy cost, and then that if that is your main source of inflation, then it that becomes a problem. Yeah. So there is like these two ranges, right? So now, if you think about SOAP, which is like even on the other extreme where you don't even have that like small amount of emission that is happening. It's like all absorbed back into the network. So SOAP is, I guess, on the other extreme where there is like no net inflation, but you have security on the chain at the same time. So then you can ask, then why can't I just pay like people less? But that makes the whole ledger like less secure. So which is like the balance that you're trying to like achieve. So for a given market cap, like from historically what we have seen is that you need like at least, I don't know, like depending on the market cap, like if you're thinking about like a ratio, at least like 0.01% maybe, which is like kind of like a good point. But I don't know if you guys followed what happened with Monero last year, where Cubic was able to like disrupt the chain by mining, and Monero I think was producing around $100,000 a day in net miner revenue, which was not enough to like keep like a $4 billion chain secure. So and like the problem with those chains is that they cannot scale their revenue, because if they scale their revenue, then it messes with the tokenomics because there'll be more miners dumping. But in our case, we can scale the revenue to like a very large number by making the blockchain more and more secure without having to actually, like put back the tokens into the market. We could like vary all of it. If miners choose to keep it, you'll be buying back from sellers who've had the token.
Thank you, sir. And if additional proof of networks are added later, will SOAP redistribute emissions proportionally or expand its total emission volume?
I mean, there are many ways to do it. Currently, the way we have conceptualized it is you also like scale the emission proportionally, basically, depending on how many chains you add, which is only possible also in our system because we have faster block times, and then we have something called work shares where we pay the miners more frequently than, for example, like Bitcoin, which takes like 10 minutes per block. So only 144 people get paid every day on average. So which is the difference?
Okay. So, sir, I have a question. So, what's the concurrency model for transaction execution within a zone? Are transaction parallelized or statically executed?
Uh,
Statically
yes,
executed.
yeah. I mean, it is sequentially executed right now, but we do some pre-processing and to remove if there are bad transactions. But we have designed it such a way where you could parallelize it when we need to. So the way we do it is using something called access lists, where every contract that you are going to interact with on it during a transaction, you got to add that into like this list, where if two transactions don't touch the same contract, then you can execute them parallelly, which is like possible already to do. We haven't done it yet because there is like we're doing around like few TPS now, so it's not going to be a problem because compute and SSDs have like developed so much in the past 10 years. So you could basically comfortably do like 1,000 TPS on a single chain without doing any parallelism. So, which is like, what Solana does. So, if you reach that kind of a market cap, then you'll have to think about it. But we have designed it in such a way you could already do it.
Okay. So, and how does SOAP handle price volatility in parent chain rewards?
Yeah, I mean, it we don't really control, right? So we just get what we get, but on average, it will be equal to the amount of Quai we give out. We don't really control it. You cannot control it. That's the thing about proof of work systems. It's like a statistics space. So, yeah.
Yeah, great. And by Quai Network, what is the maximum transaction per second we can reach?
If the protocol allows for up to 256 chains, so technically that would be like 256 transactions per second if you were to expand to all of it. Yeah, that is the beautiful part about it, where you could scale, you could just add more TPS by having new chains, and then design it's done such a way where you could also like send money between the chains, and it's all handled in protocol. There is no bridge, there is like no third party that is like there is no risk. It's all like managed and guaranteed by the protocol.
Great, sir. And do you enforce a global gas limit per transaction instead of dynamically adjusting it based on zone activity or based on liveness matrices?
We actually removed what Ethereum had, which was like the base fee, which the whole idea was to make it incentive compatible. Our whole thesis is that you could scale the chain, so we keep it fixed. But the way we keep it fixed is by tying the fee to actually in the other token, which is like the the one I talked about as the energy dollar. So we keep it as it's called chi. So there are thousand chits to have a chi. So our transaction fee is actually 5 chits for every 21,000 gas, I think, is like how the math is done right now. So it is like a fixed fee. It will never scale up, and it will always be like 5 chits for 21,000. So like a regular transaction will always cost 5 chits basically.
Yeah, agreed. So, if can you please explain energy dollar?
Yeah, so that is one of the innovations that we made is where the amount. Okay, I guess if you want to understand it from like a very basic level, just think of it as you have a token which is emitted proportional to the amount of hash that is put in to like mining it basically. So just if you just think about that statement, so what that tells you is the amount of token that is in the market is proportional to the amount of energy that was cost to like burn it. But that itself doesn't make something like stable or like that is not a dollar, because you could be doing anything with that energy, right? So you could like I don't know, you could be like throwing a coin, or like you could be like doing whatever, like physical activity, like that doesn't really make it like a stable coin or energy dollar. So once you understand that, where you have like emission of a token proportional to the amount of energy that is gone into like producing it. So now you need a market, right? So you need a market where this token, in fact, if you want to like get out or to any other like quantity, for example, dollar or any other token, then it has to be redeemable, right? So the way you have a redeemable token is you have a market. So where people are, mining it and then selling it to the people who want to use it. So if you think about that market dynamics, then let's say I have one chi, right? Let's say it cost me $1 to produce. So if miner is given an option, the only reason he will produce that chi is if someone is willing to pay more than his like production cost. So since it's an optional, so like that's how you get that property. And there is another mechanism where in the protocol itself, there is an exchange rate that is controlled based on the swaps that are happening between the tokens, and based on like how many miners are picking like either of the tokens. So there is a controller that we designed that basically pegs the it's like a free floating like exchange rate that tries to keep it on the production cost of the of like production of the token. And then the starting point that we set was to like close to around $1. I think it's like hovering around like 70 cents at the moment, but it goes up and down because currently, given the market conditions, the miners are like not that rational, especially the GPU miners. So you have like those two systems. So where you can have a market for chi, where people are using it, and then miners are only mining it if it makes sense for them, and it will only make sense for them if they're getting paid slightly more than how much it costs them to produce. And then want to convert and then produce this chi as well, they have to like spend the equivalent amount based on the conversion rate. So that would basically, so we have that conversion system, and if you have the market, then you basically get this property of energy dollar. So I don't know if it was clear, but yeah, just let me know if you have any questions. It is a little bit complex to understand the inner mechanics, but the overall idea is that the mining gives you that pretty nice feature of being like this oracle for the energy cost. So yeah, that's how we designed it.
Great, sir. And I see the ability of Quai to maintain parity with will vary with different countries, right? So different countries will have different electricity costs. So how can we make it a universal stable coin? Like how do you
so
with the electricity prices vary? Like I mean, electricity prices varies in different countries to a constant value. Like, how can we make that to a constant?
So that's why. So it's not really. It's like you have to think of it as like a global average, like price. So before we even like launched the token, we only had Quai for like the first, I think, 2 to 3 months of the network, where we actually like measured, right? So what is the average cost of like producing a token, and that's how we like set the starting point. So obviously, if there is like more energy, it's not just about the energy, right? So you also have to think about how much hash rate like those countries have. So it's like a weighted average of like hash rate to energy, like on a global scale. But yeah, that's a valid question, and there is you can only think of it as like a global average and not like specific average, because like the people talk about how like energy costs like I think $2,000 to produce a Bitcoin, but rest of the world, like for example here in Texas, it costs like I think 80,000 or something, which is like slightly more than the actual price of the Bitcoin. But there are many other aspects that come into play. If you think about different countries, there's like subsidized energy, right? So like not everyone's paying the same. In Iran, especially, it's like subsidized by the government and the oil. So, but the more that is, like I said, that is only one part of it, right? So the other part is also like the market for it. So, but yeah, so you would, since we like started with like a point where we measured the global average for the demand, like for our token, and then we set the starting point to it, and then we let it like free float. So over a long term, if you look at how energy prices have been like stable relative to like like fiat coins in like US and Canada and many other countries actually, it has done like way better than just holding the like fiat, like for example dollar. So
Isn't Bitcoin is the energy money? BTC is the energy money.
mhm. Sorry, are you asking or are you saying?
Yeah, I'm just asking you.
I mean, it's people claim that, but it's not technically true. I mean, it's true that for any proof of work chain, you only produce how much, like you only, like I said, right? Like how much coins you produce, like how much coins in dollars you produce is equivalent to the how much of like energy that you're putting into it. So that is why like people call it energy money, but it's not energy money because you cannot spend it, right? Like you cannot spend it. You cannot, like if everyone tries to spend it, then no one can use the chain. Then that itself stops like people from using it as money. Then people say it's a store of value, but if everyone's storing it, then if no one's using it, then the only way you could have a demand for it is if everyone's hoarding it. Then it's not really money, right? So for it to be a money, like you have to be able to use it, and it also has to have like nice properties of where like fungibility, right? So where no two like coins like every coin should be like same in the network basically. So it lacks some of those properties, but which I guess is like I failed to mention is like another thing that we have in this energy dollar like chi. So we have this property of like fixed denominations. So we have I think total 14 different denominations. So like which is not the case for Bitcoin, like true in the case of Bitcoin, where you could have like many, like any denomination. Basically, it's like a floating point number. So you could have like 1.1, 1.2, 1.3. You cannot have that in our system. You can only have like one Quai, or like one Chi. Then you could have like 500 chits. Then you could have like 10 chits. So based on the denomination, which gives you that like cash-like privacy properties as well, which is quite different. Which you also need if you want to have like a large scale, like people like using your coin as money, essentially. So where it's like auditable, but it's not trackable if many people like start using it, which is also not there for Bitcoin. So but the idea is good, right? So, but it doesn't scale, which is like the main problem, which is why we designed this.
Thank you, sir. And what is the plan to drive actual demand for Quai as a medium of exchange beyond the Quai ecosystem?
Yeah, so Quai is like, that's the way we think about Quai is it being the, uh, this gateway where you could easily like get people to like move because they've already like know like how to use Ethereum or like Solana or whatever. Like they know how like programmable like things work. They've used DeFi, they've used swaps, all of that. So which is like, and like for example like now prediction markets. So Quai becomes like that the bridge that that can get people over, and once they come to our system, then you can like you will discover all these other things, and then you see chi, and then like in the future, right? So where we're headed is where you'll have a market for chi, which is like not there at the moment. The only way you can redeem a chi is by like going back to Quai and then selling it, which is like not the most ideal situation for us. So we are actually currently working on it. So we're gonna have like listings of chi, and then you're gonna have like markets for chi, where you can have like you can trade it against like a stable pair. So which will be like the start, and then the main way we think is like we have to like show it as like a way you could make payments, right? So which is like the next thing we're working on. So we have this mobile app which we were working on last year, but we hadn't like truly focused on it. But now that we have like things in place, we have like bridges and like more and more exchanges, and more exchanges coming this year as well. It feels like the right time to like launch the payments app, where using Chi, then like you could start like taking payments in it, and over a long period of time, it'll be way better than holding like dollars or like any other fiat. So, which is kind of like how we see this will progress.
Okay. So, sir, and is Chi is same like Monero or Zcash?
I mean, the only things that are common, there are different things that are common. One is, I mean, they're all like UTXO systems, based systems, but Monero and Zcash, they're completely different in their architecture of like privacy. For example, like in Monero, the way you make a transaction is you have to like construct something called a ring with there's like, I think I forget the ring size in the moment. They keep changing, and then I think it's like 15. So you basically have 15 transactions that you put together, where the amount that you actually spend is like not detectable from like any other things in that ring. So which is how like Monero works. And then in Zcash, it's completely like zero knowledge based system. I mean, it has both like zero knowledge and like regular UTXO, but in Zcash, it's like you have to generate a proof, and then where the actual like transactions is like not in the thing, but you're basically like committing to like this proof that I've actually done something, and then it's verifiable. So which is different because for Chi, we don't really have that. All we have is fixed denominations, right? Which is gives you that cash-like property that I mentioned. And the other thing is we have like something called a Schnorr signature, where many people could cooperatively also sign a transaction. That means you could get like even stronger privacy guarantees the more people use it. You could have like 1,000 people like sign a transaction where you are how much you spent is actually like hidden behind, all the other outpoints that are created in that transaction. So yeah, so that's how it's like different from Zcash or Monero.
Thank you, sir. And does maintaining two ledgers per chain affect state growth or storage requirements for nodes over time?
Good question. I mean, obviously, yeah, right. So, but we do have something called like state rent in both systems. One in Quai, for example, based on the size of the chain, it will cost you like logarithmically more to like do things on chain. And then for Chi, we have like these fixed time durations where old like smaller denominations are completely wiped from the network, basically. And the other nice thing about how we design Chi is that it's we don't really like commit to the whole state as like in a tree, for example. We just have something called like a multi-set where it allows you to like, commit to like a whole set, but it's in like a linear fashion where you could have, let's say, like 1 billion writes to the disk, but you don't have to like reconstruct roots, which is like the most expensive. But you have to do that in Quai, but you don't have to do that in Chi, which is like the perfect architecture where you just have like disk writes with being the bottleneck for how many like transactions you can do, which is a lot more than Quai. To give like perspective, a single like let's say Ethereum transaction does like around 140 like IOPS on the disk. So, but it's like for Chi, it's only like 7 IOPS because that also depends on what storage database that you're using underneath. We currently use LevelDB, so which is why it's 7 IOPS, but it wouldn't be even that. So it's like highly scalable.
Yeah, great. It's great, sir. So I guess Bumsy raised his hand. So Bumsy, can you talk now?
Hey, hi, everyone. Hi,
Yeah.
Shikhar. Hi, Karthik.
Hi, bro.
I like the way you're explaining, Shikhar. But I just wanted to ask this thing. So, as we can see, AI agents are becoming more autonomous. Do you see decentralized infrastructure like Quai becoming a coordination layer for agents to interact, verify the work, and interact economically?
Mm-hmm. Yeah. I mean, that's it's something that we have like deeply thought about. One of our advisors and co-founders, he has like worked on something called like Turtle trees, where it's possible to do inference of like these LLMs directly on like a GPU. So it's like a cheap inference that is possible, where since we already have like a network of like GPUs that it is definitely possible for us to become that global like coordinating layer for like GPU inference. And then if you think about just AIs like transacting on chain as well, where TPS becomes like a very like high bottleneck. Like Chi is like a no-brainer for them to use. But everyone's thinking in terms of like stable coins and like putting like stable coins on chain. They all have like systemic risks because they're basically issued by the banks and then controlled by the banks. And then you also have issues of like it depegging and like liquidations and all of that, which right now like we're not doing that many TPS, but think about all the possibilities if like billions of like AI agents just transacting on chain, like it will like widen the like all the worst and the best things that can happen. So like you'll see like a lot more like possible like outcomes from these AIs like interacting, which is like also makes like Chi like the perfect candidate for it. But to answer your just like inference question, yeah, it's definitely possible. So we have plans for it. We also released a new product as like a beginning of like that step called Anthropic, where it's like a front end wrapper and like a coordinating like sandbox for OpenClaw. So that is just the beginning. So we have like definitely plans for it. Given that everything's like moving so quickly. So yeah, you should check it out. I mean, it's called Turtle Trees. I can share some links as well. So in the future, it should be like possible to like where we headed is we're gonna have AI agents like running on your own device, right, where you're not sharing all your data with these companies. That's only possible if like your hardware can handle it. So which is gonna be like very important because no one's gonna be willing to pay $3,000-4,000. I mean, right now it's like more than $10,000 for something that you can run locally, but ideally you run it on like something that costs like $1,000, right? So
yeah, makes sense.
That's
and yeah, correct. Yeah, makes sense. One more thing is that even the top tier labs that we have right now, Anthropic or OpenAI, they're currently subsidizing the credits a lot these days, right? The coding plans that they have.
Yeah.
It's
around 10%, like the true cost. For example, like I pay $200. I pay like $400 a month, but I probably use like $5,000 a month, right? Like doing random things. So, which is all being paid by the VCs right now and all the investments. But once it dries up, if they're not seeing results, it's gonna be like inevitable for like people to like discover new ways to like actually do it, which is like where if you see like DeepSeek or Quen models from like China, which are like a lot less which are like a lot lighter, I guess I should say, and you could run it on your computer even right now. I was running Quen on like my MacBook.
They recently released these smaller versions of the models, right? Like with something that you can run on a 24 GB device as well. The recent models that we got from Quant.
Yeah, that's where we're headed. But we can become that layer where we already have these like thousands of GPUs on our network. So we have plans for it. We just like are seeing where it's headed, and we're also building the infrastructure along the way to be ready for it when it happens.
Yeah, that sounds great. I think the compute, I mean, from beginning, if you see, blockchain has been this way for providing compute as well, not just a store of value. Of course, the payments will always be the hash fund use case, but I can see the compute as well being a major use case for AI agents as well. Now that we see intelligence being a service that a human, I think that will get a basic human need going forward, right? Intelligence as a service.
Yeah, I mean, it's only possible also if you think about it in proof of work chain, because you have like three things, right? One, you have energy, where you have like incentive to have like low cost power, right? And which leads to the innovation of that. So which is already like something that Bitcoin has done, and like East Texas, where these huge rigs, they like shut off their mining and then like give the current, like the electricity back to the grid. And then you have obviously compute, which is like not there in like a proof of stake setting. So you only have GPUs in proof of work. So, and then you have payments, like, which is like the three things you need to build that. And it's all possible like directly on like, one network. So yeah, I agree.
And there is this saying that blockchain was actually built for, was not actually built for humans, because AI agents are because the complexity that comes with the on-chain experience and all. It makes more sense for AI agents to take care of the on-chain stuff. I mean, now it's getting simpler with all the account abstraction, but usually even for a normie to use, do all the staking and stuff, it's still it's still like a lot of complex stuff for a normal user, right? An end user, right? If someone watches some content on Netflix, they don't really know what actually going on, what actually going behind, right? So when a normal user doesn't need to know how exactly on-chain works or how exactly blockchain works. I mean, yeah, sure, they can know the perks and all, like, yeah, you're getting complete control over it, privacy and all, but they don't need not to know how it actually works and all, right? All the how actually the compute works, the proof of work and all. I mean, as a developer, of course, we should know and we have to build it, but the end user need not to know it, and they can just pay monthly. There can be services or app chains built on top of the network that we have right now on the computing network. So they can just pay some monthly subscriptions or something, and they can just get agents which are basically let's say like open cloud agent that is running on your compute, right? Quai Network compute servers that is decentralized. So they don't have to worry about that, but still they are getting the perks of the decentralization. Their agents are completely are in their control, right? So it's like builders building dApps on top of the existing network that and providing it as a service to them, like a monthly usage or like based on their usage or maybe monthly subscription or something like that. So what's your take on that?
Yeah, I mean, I feel like if you think about any like industry that has tech developed and gotten more efficient, even like for example like movies, and like how now it's all like subscription based, where you're paying like a monthly, which is what is going to happen now. You're paying for like fixed use, and then over time when you have these like networks where you can do like inference for very cheap and verifiably, and get pay proportionally, or like amortized over like a large group of people. I think that's where we're headed for sure. But we don't know how long it's going to take for these models to become more efficient. But something to see for sure. We just have to be ready for it. We have the network. We're building the AI infra that is also needed when we get there, and also like build useful things along the way.
Yeah, and if you see compare from last year to current state of the open source model, it has grown a lot, significant improvement I can see. I regularly use Minimax 2.5, and also the Kimi models are also good. But yeah, all-rounder, I would say like Minimax is actually good. I have it set up for my OpenClaw agent. Like it runs 24/7. Have cron setups and all over there, and I think it's equally it's as good as Sonet 4.5, so 4.6. I can see.
Nice. Yeah. I haven't really used Minimax. I just have like the Codex and Gemini and Lot setup, but yeah, definitely something to watch.
Sure. That's also a model from Chinese labs, I believe.
I think so. Yeah, I think it's all like under the Alibaba like group. They work on it. So
yeah, that's all from my side.
yeah, thanks for your questions.
Yeah, sir. I think we're about time.
Oh yeah.
Can you wait for around 2 minutes if somebody from the audience having questions, and we can
No
conclude
problems.
it.
Yeah. Yeah.
Hello, I am Kishore. Like, can I come in?
Yeah.
Yeah, I like the session was good. The questions were great. I had a great time. just to end the session, I would like to ask one question. Like, it's a very serious kind of a question. Do you think if money is supposed to represent stored work, so isn't trying issuance directly to hashes the cleaner model than periodic halvings, which we are used to right now in proof of work? What's your take on this?
You mean like comparing to like proportional? Yeah. To like chi, for example, right?
Yeah, exactly.
Yeah, right. I mean, it's you know, like it's the same problem, right? With where like all the Bitcoin that has been mined are like with the people already, right? They will never be diluted, and like how is like the next generation gonna acquire that wealth? Which is like the same model, like where our generation has issues with like purchasing land or anything for that matter, because it's like it's all so much more expensive relative to like the income. So that is like one, right? And then obviously if you have it proportional where to the energy, and like nobody can just like print it out of thin air, which is like what happens with fiat, which is it's definitely better according to me, compared to the the regular like emission model where the early adopters are are like, actually, if you ask me, they become like the bottleneck for growth, which is like not the case if you have it proportional.
I think that's up to the question, sir. I think. Thank you so much for joining. Really had a great time hosting you. Hope we'll again meet some other time.
Yeah, no
With you.
problem. Yeah, thanks, guys. Thanks for having. Keep it up. Okay, see you then.
Thank you so much, sir. Bye.